So we had just started talking about, section 2.4, where we are introducing these sum and difference formula. So basically the idea is, if you want to simplify an angle that is, not your standard angle, so it's not part of the unit circle, let's say, then we can actually use the sum and difference formulas to try and, break it down into two known angles, from our unit circle that we will be able to use to then figure out what the value of our function at that angle is. So we had actually already started working on our first example over here. We were looking at number 20 from our textbook over here. So basically they were asking us to find the exact values for the sine, cosine, and tangent functions for a given angle. And we were looking at number 20 over here, which was giving us, of course, the angle measurement of 19 pi over 12. So we had figured out the sine and cosine values for this angle, but we needed to work on tangent. So I wanted to actually ask you if any of you actually tried working on this to try and see what you were able to get for the tangent function. So this is what we had worked on last time. So we have our sine and cosine. We needed to figure out our tangent function. And if you will remember, we had broken down our 19 pi over 12 into pi over 3 plus 5 pi over 4. So we're still using that same breakdown. So we can rewrite this as tangent of pi over 3 plus 5 pi over 4. So does anybody have an answer for this, or you guys did not work on it? Okay, so if you did not work on it, of course, then you are looking at the sum and difference formula. So since we are adding the two angles over here, we're definitely looking at the sum formula. So for the tangent function, the sum formula will be this one towards the bottom. Try to make it a little bit bigger, so hopefully you can see that fraction well. So you've got tangent of u plus tangent of v on the top. 1 minus tangent of u times tangent of v on the bottom. So this is for the tangent of u plus v function. So, of course, in this example of ours, you can think of pi over 3 as the u angle and 5 pi over 4 as the v angle. So using that sum and difference formula, this will be, again, tangent of u plus tangent of v on the top, and then 1 minus tangent of u, tangent of v on the bottom. So this will, of course, translate into tangent of pi over 3 plus tangent of 5 pi over 4 for the numerator. Denominator would be 1 minus tangent of pi over 3 times tangent of 5 pi over 4. So this is what I want you guys to find out. Again, you can use the unit circle to help you out with this, but go ahead and tell me what is the value of tangent of pi over 3 and tangent of 5 pi over 4, so we can go ahead and solve this function here. So your angles are pi over 3 and 5 pi over 4, and you're trying to figure out what the tangent values for those functions is going to be. So here's your pi over 3. Here's your 5 pi over 4. Okay, looks like Abdulaziz has got something. You've got pi over 3 as square root of 3. And for the angle pi over 4, your tangent is 1. Yeah, very good. You will see for angle 5 pi over 4, our sine and cosine values are the exact same number, negative square root of 2 over 2. So when we divide sine by cosine, you will get tangent of 5 pi over 4 equal to 1. So that's good. And then when you divide sine over cosine for the pi over 3 angle, this is where we are taking square root of 3 over 2 and dividing it by 1/2. So yeah, those 2's will actually end up canceling out when you simplify this, change your division to multiplication and invert the second fraction. So you will see your 2's will cancel out, leaving you with square root of 3. So hopefully you guys are able to do that at this point. So I'm not going to take time simplifying that. So tangent of pi over 3 will give us square root of 3 plus tangent of pi over 4 is equal to 1. So that goes on the numerator. And then 1 minus square root of 3 times 1. So this is how you will basically go ahead and simplify this. And when you clean it up, what will we end up getting? So this will be our numerator. Of course, a square root of 3 multiplied by 1 is just square root of 3. So you get 1 minus square root of 3. Now, and I know WebAssign is kind of funky because it sometimes simplifies and sometimes not. Though I am not sure if it will accept the answer in this form. And the only reason for that is because you do have a radical in the denominator, right? And normally we don't leave radicals in the denominator. So this is a place, where we would rationalize our denominator. So you will notice here that our denominator is actually a binomial term, right? We have 1 minus square root of 3. It's not just square root of 3 by itself. It has that 1 minus in front of it. So when you rationalize your denominator, for these kind of functions, remember we end up multiplying by the conjugate of the denominator. So since this is 1 minus, when you multiply this, you will actually multiply it by 1 plus square root of 3. And remember, the reason why we are multiplying by the conjugate is so that we can use this property of, a minus b multiplied by a plus b ends up giving us a square minus b square. So this is how we get rid of those radicals in the denominator. Numerator actually is the same thing. If you look at the square root of 3 plus 1, if I rewrite this guy, I can actually rewrite this as 1 plus square root of 3. So you're actually just multiplying 1 plus square root of 3 into itself on the numerator part. So essentially, it's just getting multiplied into itself. And then on the denominator, we are doing, using this property, you are doing 1 square minus square root of 3 squared. So, it's going to take just a little bit of cleaning up to take care of this. So let's see what happens if we FOIL the numerator. So we'll need to clean this up. So let's see, when we try to FOIL it, what will we have? 1 plus square root of 3 multiplied into itself. So what do you think this numerator value will come out to be? And then of course, we can go ahead and clear up our denominator while you guys are doing that. So 1 minus the square root and square cancel out on the denominator. So you get 1 minus 3, which basically gives us -2 on the denominator. Okay, let's see, Abdul Aziz, you've got 4 plus 2 times square root of 3 for the FOIL. All right, let's check that. So, of course, 1 times 1 is going to be 1. 1 times square root of 3. Same thing here, 1 times square root of 3. And then these guys at the last term will be square root of 3 multiplied into itself. So that's going to be a square. And, of course, the square and square root will cancel out. So you've got 1 plus these guys are the same. So 2 square root of 3 from here. The square root and square cancel out. So you are left with just 3. So yeah, very nice. 3 plus 1 will give you 4 plus 2 square root of 3. Alrighty, so that leaves us with 4 plus 2 square root of 3 divided by negative 2. Now, of course, this is still a fraction. So you can see 4 on the top and the 2 on the top, will have a 2 in common with that denominator. So basically, you can just separate this out and simplify your fraction over here. So the first fraction, 4 divided by negative 2, will just end up becoming negative 2. Since I have a plus sign in the middle, but then my denominator is still negative 2, plus and minus will just end up becoming minus here again. 2 and 2 will cancel each other out, so you will be left behind with square root of 3. So these guys will reduce down. The 2 over there cancels, and this will be your simplified answer. So just keep in mind, we do not leave the radicals in our denominator, so we definitely want to rationalize our denominator. So, of course, that is the algebra part, but as far as the, solving this value goes, we started out by separating our angle, 19 pi over 12. We'd already figured out, what those two angles were going to be last time. Plug it into your formula, and then, just using the values of tangent of pi over 3, tangent of 5 pi over 4, you can see we are able to simplify that. And then the last part is just cleaning it up into, a nice value, whatever it comes out to be. So questions on this one? So obviously you will see, a couple different examples on these types of questions in your homework. So this one was number 20. Let's look at our next type of example. And this one is still kind of asking you similar kind of thing. They are saying write the expression as the sine, cosine, or tangent of an angle. So they're not asking you to find the value of the angle, but they're asking you to clean this up either into sine, cosine, or tangent. So this one is kind of working backwards because you're trying to figure out, which formula can I use to try and consolidate this down to, sine of this angle or cosine of this angle, tangent of this angle. So we are looking at number 32 over here. So look at the function and tell me which formula can we use to just write this as sine, cosine, or tangent of something. And of course, you are looking at the same sum and different formulas from here. Okay, so Abdul Aziz, you're going with the tangent of u minus v function. Yeah, and the reason we know that you need to use the u minus v function is look at the way this expression is given to us. We have tangent of 1.1 minus tangent of 4.6 on the top. So you have the minus on the top, and then the 1 plus, tangent of 1.1 times tangent of 4.6. So minus on the top, plus on the bottom. And that definitely comes from your tangent of u minus v function. So this is the function that, you're basically given, and we have to simplify it and put it into this single tangent form. So for number 32 over here, so when you simplify this, what does your final answer end up looking like? So this is coming from the u minus v. So the first angle is u, the second angle is v. So when you put that in the formula, you know, when you do u minus v, that's going to be 1.1 minus 4.6. So what does your final answer end up looking like here? And is tangent an odd or an even function? Okay, very nice, Alicia. It's odd. And we don't leave our answer in this format because this is not our final answer. What's our final answer going to look like for this function here? What's 1.1 minus 4.6? Scotty, I'm not sure why you got negative 0.3746. Because you're literally just doing 1.1 minus 4.6. We're not figuring out the function value. So you don't have to do tangent of 1.1 minus, just the 1.1 minus 4.6. Yeah, that's what I thought. So we don't want the value, you know, we're just trying to figure out what the tangent function itself is going to be. So this is why I was asking you if tangent is an odd or even function. Because tangent is an odd function, your final answer is actually going to be, remember, you can bring the negative outside and do tangent of 3.5. So this is actually how you will end up writing your final answer, not with the negative inside, but using that property that it's an odd function, bring the negative outside. So everybody okay with that? Why we got the negative outside of our sign, in front of our function? Alrighty. So again, like I said, this was just kind of, you know, going backwards and trying to identify which function this would be coming from and then simplifying your answer based on that. Okay. Okay, so this one is asking us to find the exact value for our expression over here. And we're looking at number 38. So this one is saying, as you can see, find the exact value of the expression. So again, no decimal answers. They want us to leave this as an exact. So you are, again, first of all, trying to identify which formula can I apply to this example over here. So when you look at number 38, which you know, formula do you think we can use from our sum and difference formulas? Sine of u minus v. Okay, so let's take a look. You have sine first, then cosine. We have a minus and then cosine and then the sine function. So if you look at the sine of u minus v, you will see same setup. So sine and cosine, then a minus sine, cosine, and then the sine function. And you know, of course, your angles end up switching places. So very nice. Let's take a look at this guy here. So this is, as you can see, given to us in degrees, sine of 100 degrees, cosine of 40 degrees minus cosine of 100 degrees sine of 40 degrees. So if we are using the sine, or well, actually not using, but that's what this comes down to be, u minus v formula, that of course tells you this is angle u, angle v, angle u, angle v. So what does this guy simplify into? Yeah, sine of 60, right? Because you've got sine of 100 degrees minus 40 degrees, and this will come out to be sine of 60 degrees. Now, can we find an exact answer for sine of 60 degrees, or will we end up getting a decimal answer for sine of 60? What do you guys think we will end up with sine of 60 as? Is this one of the angles that falls on the unit circle? Yeah, so what will we have for sine of 60 then? Let's see, I've got square root of 3 over 2, pi over 3, 3, square root divided by 2. I'm guessing you meant square root of 3 divided by 2. Low. 2 is really the same thing, okay? And I think I do have my unit circle here, yeah, because we used it. But yeah, your 60 degrees is the pi over 3, but since they're leaving it in 60 degrees, we'll just keep it the same. And so when they're asking you for sine of 60 degrees, that's of course your y coordinate, so that's the square root of 3 over 2. Alrighty, perfect. So you do have an exact answer for this, so we can actually go ahead and put that down. And remember, that's kind of why we're using the sum and difference formulas to try and bring them down to an angle which will be easy for us to solve. So something on the unit circle definitely makes it a lot easier for us to solve. So that's kind of what we are trying to do with these examples here. All righty, nice job, guys. Very good. Let's see. The next example I have for us is 46 over here, and this one is a little bit of a different type of example. So look at the instructions that we have here. So they're telling us to find the exact value of the trigonometric expression, which for us is cotangent of u plus v. The information that is given to us is that the sine of u function is equal to -3/5, and they're telling us specifically which quadrant our u function is going to fall into. And then they're actually also telling us cosine of v, which is positive 15 over 17. And then they're telling us which quadrant the v angle falls into. So can you tell me for the u angle, which is between 3 pi halves and 2 pi, what quadrant that falls under? So for angle u, what quadrant are we looking at? Yeah, very nice. This will be the fourth quadrant. So, if you think about your unit circle or just the X and Y rectangular plane, this angle is going to be falling in this quadrant right over here. So 3 pi half, of course, this is angle 0 for 2 pi. So this is the quadrant we're looking at. And then where is angle V going to fall into? What quadrant is for angle V, 0 to pi halves? Yeah, very nice, Billy and Katie. It's going to be quadrant 1. So, of course, you are looking at this quadrant over here. So we need this information because, we have to try and actually come up with quite a lot of missing information. You can see our example here is a cotangent function. So cotangent of u plus v. If you look at the formulas, you will see we only have sum and difference formulas for sine, cosine, and tangent functions, right? We don't really have them for cotangent. So that means we're going to have to convert this into its reciprocal function, which is going to be the tangent function. So we will need to rewrite this as 1 over tangent of u plus v, because we cannot solve it, by keeping it the cotangent function. So that means we will be using, that tangent sum formula to try and simplify this. So, of course, if they're giving you the sine and the cosine values, based on that, we will need to come up with our tangent values, both at the u and v functions over here. So let's go ahead and, put this on our notebook, and let's try and simplify this. I'm actually going to clear this out. Let's put as much information as we can over here. So you are given cotangent of u plus v. To solve it, we are going to have to solve 1 over tangent of u plus v. Okay, and they are telling us, let's see, sine of u equals -3/5, and u falls in the 4th quadrant, 3 pi over 2 between 2 pi, and they're telling us cosine of v equals 15 over 17, and of course this angle is in the 1st quadrant, so between 0 and pi. All right, so this is the information that we have. So you can see we have the sine of u function, but we do not have the cosine of u function. So we need to find that. We have the cosine of v function, but we do not have the sine of v function. So we need that because, of course, you need cosine and sine at both these angles to try and come up with your tangent function. So what we are going to do is let's use our rectangular coordinate plane over here and try to figure out. Okay, this is what. Okay, so obviously if this is a quadrant 1 angle, you can kind of draw your right triangle looking like this. And your quadrant 1 angle, remember, is angle V. So that is going to be V over here. Now they're giving you cosine of V equals 15 over 17. So remember, your cosine function is defined as adjacent over hypotenuse. So that actually means 15 is going to be the measurement for your adjacent side. 17 is going to be for the hypotenuse. So with respect to angle V, the adjacent side is going to be this one. So this is going to be, 15 units. And the hypotenuse is, of course, across from the 90-degree angle. So this is going to be our hypotenuse, which means we don't know what the opposite side is. So can you tell me, because you will need to use the Pythagorean formula here to try and solve this triangle and find that missing side. So what is that opposite side going to be with your Pythagorean theorem? 8 over 15, Abdulaziz, for the opposite side? Yeah, just 8, because you're giving me the final answer and I'm not looking for that. So just to refresh your memory, guys, remember you can think of this as side A, side B, side C. So by your Pythagorean theorem, you have a squared plus b squared equals c squared. Using that, this side will be 17 squared. Let's say b is missing. A is going to be 15 squared. So you solve that, you get b equals square root of 17 squared minus 15 squared, and that should come out to be, I believe, the answer that Abdulaziz had. Yeah, Shu, you also got the same thing. The 17 square minus 15 square gives you 64, and square root of 64 is going to be 8. So our missing side here is going to be 8. So, honestly, instead of even going the route of finding cosine and sine of v, you can actually dive directly into what the tangent function is going to be at angle u, because now that you have all 3 sides, you can find tangent. And we were actually using angle v first. So now we can find tangent of v. Tangent is opposite over adjacent. So, that would be 8 over 15, which is the answer that Abdulaziz was giving us earlier. So that's how you find, your tangent value at this function. And obviously, this would be the same process if you needed to find your missing sine and cosine function values also, depending on what example you are looking at. So now we want to repeat the same process for our quadrant 4 angle, angle U, which is between 3 pi halves and 2 pi. So I'm actually going to change my color over here, and that's going to be, trying to think, because this will be going this way. How do I run my triangle? I think it's actually just going to end up looking like a reflection of our top triangle here. So let's do it this way. This will be our 90 degree. And then this here will be our angle. You remember these are all central angles. So angle U, we have sine function, which is -3 over 5. So remember, sine is opposite over hypotenuse. So this will be the opposite side. This will be the hypotenuse. Your hypotenuse is always going to be a positive number. So that negative has to go with the opposite side. And if you think about this, guys, it makes sense because in quadrant 4, our x coordinates are positive and our y coordinates are negative, and sine is, of course, your y coordinate. So that makes sense. In the first quadrant, obviously both our x and y values are positive, so you can see everything stayed positive here. But for quadrant 4, the sine value is going to be negative, and of course that would be the same kind of consideration you would have to take if you were in quadrant 2 or quadrant 3. What those signs on your functions need to be. Okay, so we've got our opposite and hypotenuse. So of course we need to find our adjacent side, which will of course be this side over here. So again, you can use A, B, and C and try to figure out what the missing side is going to be. So what do we have for this guy here? Okay, Shu, I've got 4 from you. Okay, looks like that's the only answer I have so far. So, of course, you are looking at 5 squared giving you 25. Now, there's a reason why I left my -3 in parentheses. Be very careful, because -3 is a number and you square the entire number. So negative times negative will become positive. So you will end up getting a +9 from that and not a -9. So just be very careful, when you're dealing with these negative signs in there. Yeah, very nice, Jack. So you will end up getting square root of 16 from here. And of course, square root of 16 ends up giving you 4. So our missing side is going to be 4. And now that you have both the opposite and the adjacent sides, again, you can go directly to your tangent function. So tangent of u is going to be, again, opposite, which is -3. Adjacent is 4. And again, we had talked about this in chapter 1, guys. Anytime cosine or sine, one of those functions is going to be negative, your tangent function will end up being negative. So obviously, since your sine was negative, tangent will also end up becoming negative. So now we have our tangent value at angle U, tangent at V. Now you are ready to go ahead and solve this equation over here. So let's come back down here. We've got cotangent of U plus V, which is 1 over tangent of U plus V. So, this will end up staying in the denominator. Now, remember, tangent of U plus V also gives us a fraction. So this entire fraction is going to end up staying in the denominator. And then, of course, we'll have to clean this up when we get to our final answer, but that's basically where you are starting out with. So this is going to be tangent of U plus tangent of V, and then this is divided by 1 minus tangent of U times tangent of V. So I'll give you guys a minute or two. Let me see, once you plug in those numbers and try to clean up your answer, what you come up with. So when you have your answers ready, let me know what you think your final answer should be. So, of course, if you just look at the denominator part, add the -3/4 with the 8/15, simplify that fraction. On the denominator, you first want to multiply -3/4 with 8/15. Whatever that fraction comes out to be, you will subtract that from 1. So you will need to clean up both your numerator and denominator individually, and then try and come up with, what happens when you're going to be changing your answers around. Okay, so I've got 7/5 and negative 84 over 13 as the two answers I'm seeing. What else are you guys coming up with? Okay, let's see, Jack. You've also got negative 84 over 13. Okay, same as Abdulaziz. Okay, so let's break this down step by step while some of you are probably still finishing up. Can you tell me what we get for the numerator when we add these two fractions together, negative 3/4 plus 8 over 15? Yeah, it will be a common denominator of 60 between 4 and 15. So what does our numerator come out to be when you simplify that?
Negative 13.
Yeah, very nice. It will be negative 13 because, of course, you would multiply this side by 15. And you don't have to do this by hand. If you guys just want to put this in your calculator, I'm okay with that. But if you do it by hand, then, you would multiply the left side fraction by 15, the right by 4, and then you would subtract your numerators, which is where the negative 13 over 60 would come into play. Okay, so again, we're taking it step by step. So can you tell me when we multiply just these two fractions, negative 3/4 with 8 over 15, what does this product come out to be? Negative 2/5. I believe that's right. Yeah, that's what I have. So basically what happens then on your denominator is you just by multiplying the two fractions, you get negative 2/5, but then we still have to do this subtraction. So we've still got 1 minus negative 2/5. So, the two negatives basically end up becoming positives, and you end up adding 1 plus 2/5. So, when you find your common denominator, basically you're just multiplying this guy here by 5. So 5 plus 2 ends up giving you 7/5 when you're cleaning this up. So once you clean up that denominator, we've still got the 1 over on the top, and then now you are looking at negative 13 over 60 divided by 7/5. And this is where, we can do negative 13 over 60. Since you're dividing, you can multiply and invert that second fraction. So you're basically multiplying negative 13 over 60 with, multiplying it with 5 over 7. 60 and 5 can reduce down if you want to do it that way, or, however you guys normally do this. But I believe this guy comes out to be, I know I wrote it down somewhere. Negative 13 over 84 if you just clean up your denominator. So at that point, you are looking at 1 divided by negative 13 over 84. So same thing happens over here. You're doing 1 times and then you invert this fraction. So 1 times 84 over negative 13, which ends up giving you negative 84 over 13. So if you're comfortable, you can try doing this with a calculator. But the only problem with that is you don't know if you got the right answer or the wrong answer, because even if one sign was wrong or one step was wrong, you wouldn't be able to tell if your answer was right or wrong. So taking it down step by step and then simplifying it, at least you know what the flow of the process was, and if you did something wrong or not. But basically, this is where you should end up with as your final answer for this cotangent of u plus v would be negative 84/13. So questions on the process, I know you can do the algebra part, but as far as, using the triangles to come up with your angle measurements for tangent, or like I said, you could have also done this with cosine and sine that were missing, from the original, given parameters or whatever you want to call them. But are you okay with this part that we did here, coming up with our missing values? Anybody have questions on that? Alrighty. So this was number 46. Okay. Another type of example that we have. This one actually is similar, and that's the reason why I'm not doing any examples from here. It's exactly the same thing. The only difference is, instead of telling you, where your angle falls like they did here with the U and V, they basically tell you, both angles are in quadrant 3. So, they're both going to be in quadrant 3, but other than that, your process will be exactly the same. So you guys can kind of work through that. So this was the next type of example I wanted to talk about. And I know Eusebia, you had also asked me question on this one from your homework. So this is the one we had not had a chance to talk about. So let's take a look at how we can work with an example like this one here. Oops. So our instructions are, write the trigonometric expression as an algebraic expression. So obviously they want us to use, instead of trig functions, to try and write this in terms of, algebraic functions. So let's take a look at how we can solve something like number 56 over here. And this one also, we will need to use the right triangles to help us out. So let's go ahead and copy this over. So we are given cosine of arc cosine of x minus arc tangent of x. And you do actually have examples similar to this one in your handout. So right over here, it's kind of this process that we would have to look at. So you will see what happens is we end up taking, this can be as our u, this can be as our v. So we set u equals to arc tangent of 1, v equals to arc cosine of 1, and then we actually use, arc cosine of x, and we use that to try and come up with these right triangles, so that we can then figure out, what the cosine and sine for these different angle measurements is going to be. So let's try and break this down over here. So we will define this as our u, set this as our v. So basically we are looking at cosine of u minus v. So as you can see, that formula from your sum and difference is going to be this guy over here, cosine of u cosine of v plus sine of u sine of v. So that's how we break this guy down. So cosine of u cosine of v, and this will actually have a plus sign, sine of u sine of v. So using this definition, if we try to rewrite our given function over here, this would actually come out to be cosine of arc cosine of x cosine of arc tangent of x. So that's your cosine of u and v, plus then we do sine of arc cosine of x, and then sine of arc tangent of x. So to figure out these 4 function definitions over here, cosine of arc cosine of x, sine of arc cosine of x, and then the same thing with those two tangent functions. I guess I'm going to move down a little bit and do this down here. Okay, so we're defining u as arc cosine of x, and we are defining v, I believe that was arctangent of x. Yeah. So now think about how we have worked with inverse functions in the past. That's the exact same thing we're going to be doing over here. So if I am defining u equals arc cosine of x, remember I can take cosine on both sides of my, think of this as an equation. And we know cosine and arc cosine are going to be, inverse functions of each other. So essentially you can think of them as canceling out. Of course, x has to stay in the domain of the cosine function for this to work, but this would come out to be cosine of u equals x, which we can think of that as being as x over 1. So we can then use that in our little right triangle over here. So this is our angle u. Remember, cosine is adjacent over hypotenuse. So my adjacent side would be x. Hypotenuse would be 1. So now we can find our missing side again using the Pythagorean theorem. So we'll come back to that. Let's go ahead and do our triangle for the angle v over here. So same thing, you can do tangent on both sides. So that would end up giving us tangent of arc tangent of x on the right hand side. Again, tangent and arctangent will cancel out. Of course, we want to make sure x is going to be in the domain of the tangent function. So this will end up giving us x over here, and we will have tangent of v equals x. Same thing, write it as x over 1. Tangent is defined as opposite over adjacent. So when you do the triangle for angle v, again, this will be v. So opposite is x, adjacent is 1, and we have to find the hypotenuse. So now you can go ahead and find the missing side on both the triangles. So let's see what you guys come up with for the angle u missing side. So let's do the first triangle for angle u. And what will our opposite side for angle u look like? Abdulaziz, think again. That is not correct. Billy, just x minus 1? Because that is not correct either. So again, remember, this is your Pythagorean theorem. And again, if it helps, think of this as side A, side B, and side C. Same thing with the other triangle, side A, side B, and side C. So when you're trying to find your side B, it's basically going to be B equals square root of C square minus A square. Scotty, almost there. You're missing just one tiny bit on that answer. Because what's going to happen here is our C square is of course going to be 1 square minus A square. Our A value is x, so that's going to be x squared. But this will actually still continue to stay inside the square root symbol because that square root will not cancel out. So you will actually have square root of 1 minus x squared. We are not able to get rid of that square root. So this side is going to be square root of 1 minus x squared. Not a happy number, but that's what your answer comes out to be. So that's what we gotta keep it. Do we see that, guys? Yeah. All right, so can you tell me what our missing side for the V triangle is going to be? Oh, and that should be a C, not a X. So what is the hypotenuse for the second triangle? Square root of x squared plus 1. Yeah, perfect. And depending on which one you call your side, A or B, even if it switches around a little bit, it wouldn't be a problem because you have a plus sign in the middle. So, it's okay if those move around. Very nice, Scotty. Very good. So yeah, since I'm calling my side A as 1, that would be 1 squared. Side B, I'm calling the x, so that's going to be x squared. So you will end up with 1 plus x squared. If you happen to label them, the other way, like I was talking about, you can have square root of x squared plus 1. So either of those would be okay, just however you end up writing them out. We cannot do that with the minus sign, the 1 minus x squared, you cannot switch it around. But with the plus sign, obviously it wouldn't make a difference. So this side is 1 plus x squared. So now that you know all 3 sides of your triangle, you can now come back to the problem and start filling this out. So, of course, you will see over here, we have cosine with arc cosine of x. And, of course, in this case, we are making the assumption that x is going to be within the domain of your cosine function. So in this case, your cosine and arc cosine will cancel each other out, leaving you behind with just the x from this function. But we will need to use the triangle to figure out what cosine of arc tangent of x is going to be. So remember, arc tangent of x is your angle V. So you need to go to the angle V triangle and find the cosine function. So you're going down to this arc tangent of x over here and finding the cosine. So when you try to find the cosine for this angle over here, what will you end up getting for the second triangle?
Isn't it x over the square root of 1 plus x squared?
Yeah, very nice. Very good, Scotty. Yeah, so just use from angle V, sorry, not X, Scotty, you're looking at adjacent side, so that would be 1 over the hypotenuse, right? So this is what we will be using for our cosine of arctangent of x. So 1 over square root of 1 plus x squared. And we're not going to do the rationalizing and stuff at this point. We're going to go ahead and clean up what we can. And before you do your final answer, that's where we're going to do all the final cleaning up and rationalizing and whatever else we need to do. Okay, so we've taken care of the 2 functions on the left-hand side. Now we need to simplify these guys. So sine of arc cosine of x, again, remember we assigned arc cosine of x as angle u. So you're basically finding sine of u for that first part. So sine of u means we are coming to this triangle here. And sine of u is opposite over hypotenuse. So what are we looking at for this guy?
Square root of 1 squared. I mean, sorry, square root of 1 minus x squared.
Yeah, very good. So from u, the opposite side is square root of 1 minus x squared. Our hypotenuse is 1. So, of course, anything divided by 1 will be the number itself. So that's going to be just square root of 1 minus x squared. Very nice. So that's going to be for this part. Alrighty, and now we got to figure out the second part of this side, which is sine of arctangent of x. Arctangent of x is your angle V. So sine of angle V. And what will this guy end up giving us?
One over the square root of 1 plus x squared.
No, remember that was what you got for the cosine because that's the adjacent side. Your opposite would be with the x, right? From angle V, the opposite would be x. So this guy is going to be x over square root of 1 plus x squared. So x over square root of 1 plus x squared. Now, since we are multiplying, on either side of that plus sign, if it helps, you can write this as being over 1, so they look like fractions. But basically what you will end up having is on the numerator, we will do x times 1, which will give us x. Denominator will be 1 times square root of 1 plus x squared, so that guy will stay as is. Plus, again, we're just multiplying. So since that guy is in a square root, all you can do is bring that, leave that x on the outside, this x from the second one, and just multiply it with that 1 minus x squared. And then our denominator would again be the same thing, 1 times square root of 1 plus x squared. So you will actually see on both sides, our denominator is the same. So since you already have a common denominator, just leave it as is, and then just add your numerators, which we can't technically add them because they're not the same terms, but you can just put them over a common denominator. So you'll end up with x plus, and then from the second side, you have x square root of 1 minus x squared. And you know what? I would try with this to see if WebAssign would accept this as your answer, because rationalizing will actually make it look even more complicated than what it is. Because, of course, we would have to multiply by square root of 1 plus x squared on both top and bottom. So I would try this, and I have a feeling that it will actually accept your answer in that form. Yeah, because otherwise you would have to rationalize your denominator, kind of like what we did here. But I have a feeling WebAssign will accept this as your answer because you've already got enough, unknown variables in there. Okay, so question on the process again here, guys. So we looked at the arc cosine of x, set that equal to u, arctangent of x, set that equal to v. We use this formula over here, the cosine of u minus v formula, to write out our expression over here. And then once we write this out, we did our little, inverse function calculation here, tried to figure out if we put this on the right triangle, what sides are given to us, what is the missing side. Based on that, we completed all 3 sides of our triangle using the Pythagorean theorem. So once you have all 3 sides of your triangle, then you are basically coming in and filling in all these, values for the given angles. And the last part is just cleaning that up a little bit. So questions on this example here, because this is something different than, what we have done in the past. No questions right now? Okay, if you start looking through homework and you get stuck on anything, you need extra help, definitely reach out. Again, I have office hours 1 to 2, Monday through Thursday. So that was number 56. Now looking at our next example over here. And we were looking at trigonometric function of only theta. So basically they're saying, find a way to get rid of the other angles, just try and get it down to one single angle. And the second part, of course, since we're not using graphing calculators or anything like that, if you want to confirm it just to make sure you're on the right track, you can definitely use, like a Desmos graphing calculator if you want to. But right now, we're really just interested in that first part, making sure we're able to write this expression, by just using the angle theta over here. So let's go ahead and take a look at this example over here. So let's go ahead and copy this over. And this will not take us too long. We should be able to do it with the time we have left. So you have 66, which is sine of theta, pi plus theta. And they want us to leave our answers only with theta here. So, again, think of this as your same sine of u plus v, because we do have two different angle measurements in there. So again, if you go back to the formula, sine of u plus v, which is this first one, you can see it's sine of u, cosine of v, plus, and then we switch them. So cosine of u, sine of v. So this guy will be sine of u, cosine of v, plus cosine of u, sine of v. And of course, you can see the angle pi is definitely part of our known angles on the unit circle. So we will be able to simplify that one. So you will have sine of pi cosine of theta. So just following our formula over here. And then this guy would be cosine of pi and sine of theta over here. So we should be able to come up with what these values are using the unit circle. So what do you end up getting for sine of pi and cosine of pi? And again, if you want to look at the unit circle.
Cosine is -1 and pi is 0. Sine.
Yeah, very good. Yeah, because you can see your ordered pair is going to be -1, 0. So the first number is for cosine. The second one is for sine. So very nice, sine of pi. Eusebia, that's fine. Yeah, we're just wrapping up this last example here. So sine of pi actually comes out to be 0. So 0 times cosine of theta on that first part, plus cosine of pi is -1. So that becomes -1 times sine of theta. So, of course, anything multiplied by 0 is just going to end up becoming 0. So this will actually disappear, that first term. Plus or minus leaves you with -1 sine of theta. So 0 minus 1 is just going to be -1. Because, this guy's essentially gone, and you're just left with negative sine of theta. So you can see they wanted us to leave this as a trigonometric function with only theta as the angle, and you are able to do that again using the sum and difference formula, and especially because pi is a known angle. So look at the other angles also that are given to you. Given 3 pi over 2, which is also a known angle. So we would be able to plug that in easily. Same thing with this last one. You're also given pi on that example. So all of these are known angles, which you would be able to find on your unit circle. So you would be able to simplify it pretty easily. Questions on this one, guys? So again, you can see these are all examples using the sum and the difference formula, but just different ways of how you would be using those formulas and how we would be, coming up with these answers. So your last example here, number 70, is actually solving an equation, but you will see in this example also they're giving you that cosine of x plus pi. So we would have to use the sum and difference formula over here on that first part before we would be able to go ahead and solve this equation. So we'll take a look at that next time. Now, as you can see from here, we do have a pretty decent list of examples to look through for section 2.5. So we're going to try and, look through these examples. Some of them might be repetition. So if they are repetitions, we can probably skip over them. So that way, at least we know you have looked at one example for each type of different formulas in there. So again, all of your homework assignments are now available. I've also opened section 2.5 yesterday. So you have the quiz and homework for 2.5 also available. So take this week, guys, try and get as much of your homework done. I am available this week for office hours. So if you need extra help, reach out to me and I can help you out, or you can do the Ask Your Instructor link through homework also. So have a great day, guys. If you have questions, you want to stay back, you can. If not, I'll see you on Wednesday. Be careful, everyone. Take care. Stay safe. Bye, guys. And then I know, Scotty, you're staying back for a question. So will you just give me 1 second and